Okay, so we're going to talk about JSON data modeling here, and specifically for document databases. That's kind of my wheelhouse, although I spent a lot of my career working with relational databases and a lot of schemas that look like this, except a lot more complicated and a lot more fractal, if you will. So I'm going to start with the assumption that most of you are in the same boat as me. You come from a relational background. You kind of understand the benefits of the benefits and the approach of relational modeling. But you want to maybe start thinking about, oh, there's some NoSQL out there, some document databases. There's some benefits to those. I want to explore them, but we have to think about modeling in a different way. And so just a shout out here to GDG Indy. Thank you for hosting me. And here's the link to the meetup right there. So if you're watching this on YouTube, definitely come and check out this group. Go sign up, and especially if you're in the Indy area, although right now, not a lot of travel going on. So virtual meetups are in order until otherwise. My name is Matthew Groves. I work for Couchbase as a developer advocate. You can find me on Twitter there. I have a podcast and blog. Those aren't super active right now. I'm working on other stuff. I'm working on my Twitch stream. I'm working on some Pluralsight courses, things like that. And I don't consider myself an expert on anything really, but I am very much an enthusiast when it comes to coding technology, especially databases, NoSQL databases, back-end development. That's kind of my wheelhouse there. So I'm not your front-end design guy. I'm not your client-side JavaScript guy, but I'm very much into the back-end of stuff. And so we're going to talk about JSON data modeling. Here's the agenda for today, and it's kind of a smallish group. So if you have questions, want to go in rabbit holes, that's totally fine. But we're going to talk about why NoSQL, just spend a little bit of time talking about why people get into NoSQL databases, what are the benefits of them. And then there's lots of different things we could talk about when it comes to NoSQL. I want to focus today on data modeling, obviously, and JSON specifically. And then we'll talk about accessing the data, because that also factors into the model. And then migrating data, because in some situations you may want to start fresh with NoSQL. Some situations you might want to have NoSQL and SQL live side by side. I mean relational and document live side by side. And you may want to just eventually move from a relational to a non-relational database. So those are all different forms of migration that also figures into the way we model data. So why NoSQL? Relational databases are fine. They're great. They give you a lot of functionality, a great set of abstractions, tried and true language, SQL, SQL, ACID transactions, stored procedures, all this kind of stuff. But there's some reasons why NoSQL has kind of become more popular and started to take off and gain adoption, even amongst, even outside the startup, outside the Bay Area, in larger, more traditional enterprises, starting to really take off there. And I think one of the things that I want to have as a theme for today is change. There's lots of reasons you might want to look into NoSQL, but change is inevitable, and relational databases don't handle change as smoothly and as well as a NoSQL, as a sort of relaxed schema database does. And we also talk about change in terms of hardware and scale and capacity, things like that, which are very important, especially if you're working on a public-facing website, large-scale website, cloud-based systems, things like that. So NoSQL databases, especially ones that are designed to be distributed databases, they tend to help solve the problems of agility, scalability, performance, availability. We're going to focus a lot on agility here today, but there's other things that drive NoSQL adoption. So let's first talk about what NoSQL is, because in my book, it's an important word. I work for a NoSQL company, but it's a very useless word, I think, because it describes what something isn't. And as you're going to see later, it's not even really accurate anymore. So it's just basically all it means is that it's a database that's different than what we've done in the past in terms of relational. It's other approaches to storing data. This is a different categorizations of 4 different kinds of NoSQL databases. There are other kinds out there. So you can see, we've got Cassandra, and we've got Neo4j, and we've got Couchbase. They're all in this one NoSQL category. So it's a pretty broad category of databases. So the word itself is not terribly useful. So I would say try to start using one of these more specific words like document database or graph database to just drill in detail there. And then also firestore, I'm categorizing it as a document database here. But like many document databases, they can also act as a key value database if you really want it to do that with them. So the line between document and key value can be a little blurry sometimes. But we're going to focus on document today, and I just want to give a little more history about NoSQL. Is when you have a document database, it's often based on keys. So the operations you can expect are, I want to get a document by a key, set it by key, etc. And it's all key-based documents. And notice that there's no SQL I need to do that. So that's why it gets this keyword in the first place. It's no SQL, no SQL required to work with it. And then if you have a document database, your data is stored in a specific format like JSON, mostly JSON. So we can also run it through something like a map reduce and actually use that as a kind of a way to query data. And that's sort of the origins of NoSQL. And it's changed a lot since then. But that's kind of where it comes from, is those basic set of operations. You don't have to write SQL queries to work with them. And that's where we get the buzzword. So just think of a document database as the simplest type of a key value store where the value is a known format. And mostly it's JSON. There are some that are not JSON, like XML, or there's probably a YAML database out there for all I know. But for the most part, it's JSON. And so when you write code where you start with a key, you can ask the database to return the document that corresponds to that key. And the same for deleting, updating, etc. That's like the elevator pitch of what a NoSQL database is. A document database. And so why people use document databases, again, we're going to focus mostly on agility, but scalability is kind of the main reason that these were born in the first place. And if you're using a cloud-based, like database as a service, like Firestore or Cosmos, something like that, a lot of this stuff happens behind the scenes. Now, some of them may require you to take a few extra steps for this reason, but a lot of this happens behind the scenes. So we get something called a cluster here. So you have multiple machines, multiple servers, and they all are connected to each other via network, and they sort of act together as a cluster. So if we want to improve our capacity, to add more capacity to it, if we have, say, more traffic, or it's Black Friday or something like that, we can just add more nodes to that cluster to expand the amount of CPU, amount of RAM, amount of disk space, operations, etc., that we can handle. And we can keep expanding that out and adding more and more nodes. And we can also, let's say shopping season's over, we can now scale back down to save a little bit of money on our cloud footprint, for instance. So that's scalability, and flexibility and scaling is one of the reasons that NoSQL kind of came about. And then flexibility in terms of schema management is kind of one of the side effects of that. So it's easier to, there's no predefined schema. You don't have to define tables, rows. You don't have to define tables, data types, all those sorts of things ahead of time. At least you don't have to define them in the database itself. The database will just take whatever JSON you want to give it. And so some of the things that this is very helpful with is when you want to change the way you store your data. With a relational data, relational schema, that could involve, dozens of tables and, tons of different columns you have to change, and that could mean downtime or coming in at 2 a.m. on a Saturday, things like that, to make that schema change. Additionally, sometimes things like IoT, for instance, you're pulling in data from all kinds of different sources, and you can't really rely on the schema being the same from all those sources. So just ingesting that data into one place, still in a structured way, like JSON data, is a really good use case for that. And this doesn't mean that you should just put whatever you want in there, right? And we're going to talk about that a lot today. We'll talk about what are some recommendations for keeping your models sane. And availability is the other one. So again, this goes back to the cluster. If one machine in your cluster goes down, customers can still use the other ones. If you have a traditional relational database deployed to one machine, if that machine goes down, your system's down. If you have a cluster distributed database, if one machine goes down, you can have some replicas, some backup copies on other machines, and they'll still be there to serve your application, serve your customers. And this is a real life example here. This is my wife, and I just before we were watching Wonder Woman. That's how long ago this was taken. But there's a whole cluster of Coke Freestyle machines at the theater, and one of them was down for maintenance. They were refilling it or repairing it or something. But there's other machines available there, so we could just easily get our soda before the movie, even though they're still repairing the machine. They don't have to wait till 2 a.m. after all the movies are over to go in and repair the machine. They can do it right there, and customers can still get service. Now imagine if they only had just the one Coke machine, then no one could get soda during the movies. I mean, sales would go down like crazy. Same concept kind of applies here to distributed databases. And then performance is another one that people often mention with NoSQL. I'm not going to say across the board NoSQL is always faster. I think that's a blanket statement. That's just not correct. But NoSQL are optimized for specific access patterns. We can definitely say that, especially if you think about the modeling. You know, in a document can be stored as a lot of different pieces of data that's aggregated together into a root object, unlike a relational where you have to do a bunch of joins and things every time to get a complete object. So in some of those cases, it might be faster to use NoSQL. And there's certain architectural choices that NoSQL technologies also offer. So for instance, does it have a built-in cache? Or is it memory only? Because memory is going to be faster than disk, right? So if you can really make use of memory in a different way than relational, then you can get a performance boost there. That can be very subjective. There's lots of, what do you call them, benchmark reports out there. And I'm always suspicious of benchmarks, especially if they're comparing vendor A to vendor B to vendor C, because chances are the benchmark's published by a vendor or commissioned by a vendor, and surprise, it says that vendor has the best performance. They're not going to publish ones that make themselves look bad. So I'm always suspicious of those. That's why I like to focus on architecture and you know, some of the features that would improve performance. As far as use cases go, it used to be a relatively limited set of use cases. But as I said, NoSQL is changing a lot over the years, and features keep being added, and different industries keep adopting document databases, NoSQL databases. So you see an expansion in use cases that are possible. So certainly caching, session, and user profile, those are kind of the killer apps for NoSQL. I would say, yeah, definitely you should use one of the document databases or key value databases for those. But things like catalog and content management that benefit from having a flexible schema make total sense. IoT, Customer 360 is very similar to the IoT type of data ingestion use case. And even all the way down to that bottom right one, which has always been held up as, oh, you should never use a NoSQL database there with finance because we need transactions. Well, NoSQL databases have transactions these days. Not all of them, but many of them are adopting transactions and ACID transactions. So the use cases for NoSQL keep expanding. And this is just a few I've pulled from Couchbase's customer list. If I look at all the other databases, there's lots of different use cases out there. So it's also worth pointing out that plenty of companies are doing these use cases with relational as well. So relational is usually at least the mediocre choice, right? But NoSQL may be a better choice. And the catalyst is one of those reasons I mentioned before. So scale, flexibility, performance. And just a little quote here, not sure who the author is, but this is kind of the stance I take with any new technology, right? Is that, okay, well, I want to put on my resume. That's not necessarily a good reason. But you know, if I want something to work better than it is now, I got to do something different. Whether it's a different tool or a different approach or whatever it is, something different may be better. Okay, so I want to hold up here for a second. I promised Michael I would do this and see if there's any questions that have come in so far, or if you have any questions, Michael. All right, so I want to go through like an exercise of modeling some data, like a whiteboard exercise. So let's just go look at a customer, for example, here. And we're doing this as a proof of concept. We haven't even chosen a database technology yet. We're just drawing this out on the whiteboard and saying, well, here's what our customer looks like. Here's the different attributes. You may go through some sort of more rigorous framework for this, UML or some sort of design language or whatever. I'm just drawing a little, stick figures on the whiteboard. And so we can look at this and see that there's 4 different characteristics I want to point out. And as we go forward, I want to mention these You don't have to memorize these because they're all kind of intuitive, but there's a rich structure to this data. So we've got attributes like name, date of birth. We've got potentially sub-attributes. So maybe name is first name and last name, 2 different fields. Maybe date of birth we split up by month, day, year, something like that. We also have relationships. Number 2 is relationships. So we can have this customer has some sort of relationship to other customers or to purchases, products they've purchased. There's some relationship there that we're describing. The number 3 is a value evolution. So we start with one purchase, for instance, and we maybe want to add more purchases as we go. So that's just evolving the values of the data. And of course, we could maybe want to change the name or change other information about Helen here. And the big one here is structure evolution. So maybe we naively start with setting, creating a table, let's say, or saying that this customer has a property of Visa card or credit card number and expiration date, and those belong directly to the customer. Then a requirement comes down that says, oh, we need to support multiple payment options. So now that decision was not necessarily a good one. We need to evolve that structure to support multiple payment options. So how that might work in relational is we start off with a diagram kind of like this one. We have 4 tables, and they're all kind of centered around the customer, this all sort of customer-centric model. We have foreign keys that relate the contacts to the customer through a foreign key and so on. And that's how that would work. And then, so all those things I mentioned, the structure, relationships, value evolution, it's all there. The structure evolution would come when we say, okay, we need to support multiple billing options. And suppose we had a credit card number column in our customer table. Not a good design choice to begin with. I'm sure you've seen situations similar of this actually happening. But the requirement comes down and we have to have multiple payment options. We could just add another column, credit card to customer table, but then that's just going to get out of control. So the correct way to do this is to have a billing table and have a row that corresponds to a credit card, for instance. And then that billing table has a foreign key that points to customer. But if we've already deployed the first model, we have to go back and make this change in production. We have to create the billing table, create a foreign key relationship and constraint to the customer. We have to migrate the data from the customer table over to billing table, and then we have to remove those columns from the customer table. So that's a lot of steps for a relatively minor schema change. And I'm assuming if any of you work with data, your schemas are a little more complex than the 5-table schema I've shown here. So that could be a pretty serious impact on your process, on your application, on your deployment, etc. So I want to contrast that model now with how you might store data in a document database. So I want to sort of work backwards here from the relational to a document. So I'm going to start here. The relational is on the left, document is on the right. And this is a fairly straightforward transformation here. So we have a customer table with 3 columns. One of them is a primary key. And on the right, we have a document, a single document in our document database that has itself a key. And I've just made the values the same here for clarity's sake, CBL 2015. Inside the document, we have JSON values that have name and date of birth. And so you can see it's a really easy one-to-one translation here from this single table to a JSON document. Okay, so I just want to make sure that I want to pause here for a second and make sure that this is, I usually, when I do this in person, I like to look at people's faces and see do they know what JSON is? Are they confused? Do I need to stop and explain it more? But that's a little different right now. So I want to pause for a second and make sure we're good here. We're on the same page so far.
There was one question from a moment ago.
Okay.
So just because there is no formal schema, it doesn't mean the data isn't structured somehow.
Yes, I would agree with that. That's a very good comment. I would say there is no schema enforced by the database, but there is, some people call it a schema on read, right? There's not a schema on write, there's a schema on read, because you have to put that data into something to serve it back to, an endpoint or to a service in your application or to a web form somewhere, right? So you have to have some discipline about how the data is being stored as well. Yes, that's a very good point. Absolutely. Yeah, you're having problems with my sound. Yeah, I noticed that too. It's let me adjust my microphone here. It keeps going up and down. Let me see if I can get it better there. Okay. Okay, we'll soldier on here because it's going to get a little more complicated as we expand the schema out here. So let's look at purchases. We're going to add purchases now. So each customer, if you remember, can have multiple purchases. And so in this case, I'm not getting really complicated. I'm just saying, okay, here's a row of data, and it has a foreign key to the customer. And that is a purchase of a laptop at a certain price at a certain date. And so now we have to represent a customer fully, we have two tables and two rows of data, two separate rows of data. And normally you would join that together in a query or something in your application. Now, the way we'd represent this in a document database on the right, this is one possible way to represent it, is we'd have just a single document still, but now inside the document, we have a purchases array. And that array is all the different purchases that I've made. And so you can see on the document database, it's still just one piece of data with all the structure intact. So it's not flattened and shredded out like a relational database. It's all there intact in the one document. So if I wanted to evolve that value and add a second purchase item, in the relational model, it's a second row of data. So now we have 3 rows across 2 tables. With the document, we still have just the one document, but that document itself has an array that contains the different items that I've purchased. Okay? So far, so good. Now, it would be nice if we could just do this for everything and just embed everything into one document. But that's really not super practical for some systems. For some systems, it might be. That might be totally fine. That might be enough. But let's look at how we modeled our connection. So we have a customer that we want to relate to other customers. Maybe it's some sort of family, I don't know, you know, with Android, I have Android family. With Netflix, I have different accounts in Netflix. So I want to have them all joined together to one root account or something like that. So I have a connection table here in Relational that has itself 2 foreign keys. So one is the customer and one is the other customer I'm connected to with a different key. And then maybe some information about the relation. So in this case, I've put the family relation in there, brother, father, etc. So this is like a mapping table in relational databases, a many-to-many table. And this is where relational really starts to strain when you have to start building a lot of these types of tables. Now, in the document database, it's not terribly different, but again, we have a array here now. So instead of separate documents to represent the relationship, we have a embedded array that itself contains keys that can point me to other customer documents. I don't want to embed a customer inside of another customer, because then it just could be customers all the way down. You know, a customer inside of a customer inside of a customer inside of a customer, and so on. So I still want to keep the customer documents separate. If you're familiar with domain-driven design, it's this concept of aggregate root. And I like to think of document databases more as aggregate-oriented databases, because they kind of favor this grouping of data up into the aggregate root structures. But you can see here, I've got it it's kind of acting like a foreign key. It's pointing towards another customer document. I can go look it up, but the relation data is still stored here in the document. The array is all stored. It's still all in one document here. It's just the other customer is stored in a separate document. All right. Okay, now here's where it gets a little wild. And this is usually where I get most of the questions during the presentation. So let's go with the very first naive model. Maybe I'm just too loud or something. I don't know. It does keep going in and out, the audio here. I apologize for that. I get a little excited sometimes when I talk about databases. So we're going to go with the naive model of our database we deployed first. So I've got here, you can see I've got a card number column in my customer table. Now, if you have experience with relational, you probably notice right away this is probably not a good design. But just for the sake of argument, I want to go with something that's relatively obvious to refactor. So we have card number, expiration, and card type. They are right there in the customer table. And so this is how I'd model this in a relational database. I have these 4 tables. I've got, what do we got here? 2, 4, 6, 7 different rows of data in 4 different tables. So you can kind of think of it, if you're taking a customer and put it through a paper shredder and you store the shreds, that's fine, except now I got to put those shreds back together. And that can be a real problem. We try to solve it with ORMs, things like that. But it can be very tricky. With the document database on the right, I've again kind of taken a naive structure here. I've put the card number, expiration, card type at the root of the document. So again, I'm making the same mistake in the document database, but I'm doing that to make a point here. But it's still just one single document representing one piece of data representing a customer versus 7 rows in 4 different tables. Okay. Now, let's suppose we want to refactor this. This is where it gets very different. So in the relational world, I have to go through that whole refactoring process, the alter table, the new table, the foreign keys, all that kind of stuff. So now it's a better schema on the left. That's a more correct schema, I'd say, a way to store our data. I've done the same thing to the document on the right. I've moved that into a billing array so I can have multiple billing options of that customer in an array there. But there's a key difference here, and hopefully you spotted it. This is a different document, CBL 2016. This first one, CBL 2015. Both these documents can live in the same collection, the same data store, and they can coexist with each other because they're isolated. They're not relations. They're not dependent on each other in terms of what column, what fields need to be in there. Like you would, every row in the customer table has to have a name, has to have a date of birth. With the documents, I can have name in one and not in the other, for instance. Now sometimes that's really scary for people to say, well, that's just no good. I can't live with that. That's just not going to work for me. And then of course the question becomes, well, what do I do about this long term? So there's really 3 approaches to this. And it depends a lot on your use case, what you want to accomplish. So remember that we have, I skipped ahead. We have the one document here in the one format, and we have another document in a different format. So the first approach is we can just leave it as is and have our application handle it differently depending on the structure of the data. So if my application is still going in and out, it's driving me crazy. It wasn't doing this all day, and now it starts doing this. Move this up here. Okay, I'll see if that works. So we can keep them as they are, and then we just have like an if statement in our code somewhere that says, well, if it's this format, then do this. If it's this format, do something else. And we can actually put like a version number in our documents to kind of help us with that. So we don't have to guess. We can just go off the version number and go off that logic. The second approach is, well, we're updating our data to this new format going forward. So go back to the old ones and change them all over to the new format. And we can do this without taking down the database, without having any sort of downtime. We can do this pretty much whenever and make that change as we go along. So like a big boom of changing all our documents over to the new format. And the third approach is kind of a hybrid. So we can say, when this document comes in, we're going to recognize it's the old format. And when we save it, we're going to save it into the new format. So it's kind of an in-process, kind of evolving data as we go through. And this is something, if you've had to dealt with changing password schemas in the past, if you're on MD5 and you wanted to go to SHA-1, for instance, you're probably familiar with this in Relational. It was a real pain in the neck to do it. But it's the same kind of approach with the structure of our data. So those are the 3 approaches to dealing with that kind of change in the data there. But the key difference here is that changing a schema may have some impact on our system in production, may result in downtime or read-only periods or late night sessions. With a document database, we can kind of do it on the fly. Okay, so now the next question is, well, okay, Matt, you show me the arrays that are embedding data. You've shown me the arrays that are kind of pointing to other pieces of data. When should I do one or the other? It was kind of obvious the way I set up this data, which one we should use, but it's not always obvious. So there's some rules of thumb here, some strategies, and these are rules of thumb because it's not an always never situation. This is okay, start here and change it if you have to. So if the relationship is one to many or one to one, then nest the data. Just nest it up into aggregate, sort of collapse those auxiliary tables into a main document. So purchases made sense to do this here. If it's a many to one or a many to many, then kind of the opposite, right? We're going to store those related data as separate objects. So in this case, I've got a connections array that points to 3 other customer documents, let's say. That's it. That's just kind of the simple rule. And there's going to be some more rules of thumb as we go along, but those are kind of the simple guidelines to, okay, well, when should I do one? When should I do the other? Okay, and the last thing before I go on to data access is there are some tools to help you through this, right? So with relational databases, you often think about the database itself as a modeling tool. And that, I don't know if that's really the best approach. I mean, kind of modeling it separate from your database is a good idea anyway, but there are a lot of modeling tools out there that support document database, that support NoSQL. So Hackalate is one that I believe supports a Firebase and Firestore. It also supports like Mongo, Elastic, Cassandra, and Couchbase, which is why I know about it. Irwin supports. I don't think any of the other ones support Firebase, but Irwin supports Mongo and Couchbase, and I think Idera just supports Mongo for now. So if you have these tools at your current enterprise, you might already have licenses to these sorts of things. If not, if you're using other modeling tools, those might support it as well. But you might want to look into these if you're looking to have a more formal way of modeling your data that you can check into source control, you can share with your team, you can go through screen. In our case, we're in a very much a screen share, communicate over Hangouts, communicate over Zoom, so we can all kind of share the screen and go through the modeling exercise that way. Okay, so I'm going to pause for questions here. The putting the shreds together really stuck with you. Yeah, I don't think I invented that, but I think I heard someone say that, and I really, really like that analogy. Yeah. Okay. Yeah, some really good comments there. Excellent. So I'll keep on going. Okay, so some more rules of thumb here in terms of modeling your data. And so now we got to think about how you're actually accessing your data. So remember, going back to this very simple set of access options, you're going to access data by key. You're going to access a document by its key. You're going to get the whole document by its key. You can update it by the key, read, update, delete, etc. by the key. So just going off that assumption, which every document database should support that. So I think this is a fair set of rules of thumb that can apply across the board. So if your reads mostly involve the parent fields, so in this example here, name and date of birth, then store those children as separate documents, because you want to keep the footprint of the read down as small as possible. You don't want to send a whole document full of all your aggregate data across the wire. So you want to keep those things separate if your reads are mostly those parent fields. If the reads are mostly parent and child together, like a shopping cart, for instance, makes sense. I'm going to show you the shopping cart. I'm going to show you all the items in it and the root data about it, your name and your where you're shipping it to, those sorts of things. Then it makes sense to store them as nested objects, because now you want to cut down on the number of lookups you want to do. If you're going to look these all up at once all the time anyway, you may as well store them all together. So instead of, in this case, we have one document and then for the shopping cart, and then 2 documents for the purchase. That's 3 total lookups. If we embed everything here together, it's 1 lookup. So if you're going to be doing the parent and child fields together. As far as writes go, kind of it works the same way. If we're going to write mostly to the parent or to the child, not both together, then we store them as separate documents. So kind of our connections example, we're going to mostly write to a customer or some other customer that the customer is connected to, store them separately. And here we go, just to be complete here, if the writes are mostly parent and child together, store them as nested objects, because again, we're going to be making all these changes into one single update or one single write operation. And that's going to cut down on our round trips to the database. So I'll just show all the rules here on one slide. Usually I give people a second to get their cell phones out and take a picture of this. But of course, since you're at your desk, you can just hit the print screen button and there you go, you're done. And I'll share these slides later after the session as well. I told Michael I'd share them with him. So there we go. Those are kind of your basic rules. Now, any other rules that I'm going to, well, they're not rules, they're rules of thumb. Any other sort of guidelines that I give you here from this point on are going to vary based on which database technology you want to use and which ones, what their capabilities are. So I'm going to have to use some specific examples at this point on. So I'm going to start with Couchbase because it's the one I know the best. And there are lots of ways to access data in Couchbase beyond just the key value operations that I mentioned. Because I've been talking about mostly that up to this point. But most of them these days have more than that. They have more than just key value access. You got to think about how you're going to interact with your data. So with Couchbase, there's 5 different ways here I've shown. I'm going to highlight just 3 of those. So the key value operation, I mentioned that already. I'm going to show you a quick example of that. Nickel, Couchbase supports SQL as a query language. So remember earlier when I said that NoSQL is a lousy term and it's inaccurate? That's true because Couchbase supports full SQL. So it's a NoSQL database that has SQL support. And now you notice there's an extra step involved in these indexes. So you can't just take a key value and go look at the document directly. So these all involve at least one extra step to get the data out. So they're not going to be as fast as key value access. So there's other reasons we might want to use those. And full text search is another one, kind of like a text-based keyword ranking lookup. It's another way to access data. I'm not going to talk about MapReduce views. I'm not going to talk about analytics today, but those are other options that Couchbase has. So I know Michael was mentioning C# earlier, so I'm a little less nervous about showing this slide. Because I'm a C# developer, I'm a .NET developer. You don't have to understand .NET for this presentation. This is just me kind of showing you key value lookup is very simple, very straightforward. You have a key. I'm going to get that key. I'm going to, in this case, in C#, put it into a shopping cart object. And I'm going to create a shopping cart. I just say, okay, insert with the key, which in this case, it's called ID, shopping cart 1. And the content of that document will be whatever's in my shopping cart object. Easy as that. Key value is always going to be the simplest, fastest way to operate a document database, just bar none. So with that in mind, if you want to optimize for key value as much as possible, and you should, there are some things you can do to make this a little easier on yourself. So these are some recommendations. Some people just use GUIDs or UUIDs for keys. It's totally fine if that works for you. But if you can, it makes sense to kind of make those keys maybe more natural keys so that they correspond to a username or an email address or phone number or whatever. And that makes them more human readable as well. So I'm looking at a bunch of keys. I see GUIDs. That doesn't mean anything to me. I have to go deeper to figure that out. But if it's human readable, I can figure out what's in here. This is probably users. Or this is probably products, etc. And deterministic, and I'm going to show what deterministic means in a second. That's going to help us go from document to document without having to worry about joins and things like that. So if your document database doesn't support joins, then this is one way you can kind of get around that. And then making them semantic as well, give them some meaning. It kind of helps with the human readable, but also gives it some meaning that people can ascribe to it as they're looking through the data, as they're writing code to deal with them. So here's some example. Let's say I'm writing a blog, creating a blog system. I have a document with the key of author : Matt. So we can tell from that this is an author. The author's name, username probably is Matt, and we have information in that document about Matt. My password, my name, my shoe size, whatever. We have another document called author : Matt : blogs. So if I log into the system, it will know from me logging in that, okay, I can look up the blogs Matt's written by just adding : blogs to that and looking up that document by key. So I can, in a deterministic way, get to that list of blogs without having to write a query. And then further, if I have a list of slugs, let's say, in that document, I can go through those and look up individual blogs by just saying blog : slug. In this case, C#8 features might be a blog post that I wrote. And so on. There's maybe comments that are attached in a separate document. People leave comments on the blog. They can be in that document there. So I've gone through this whole structure, this whole path of going through my documents. I don't have to do any sort of joins. It's all key-based lookups, very, very quick, semantic, it's human readable, and I'm getting the most that I can out of key value lookup. Subdocuments. This is another thing to consider with your NoSQL database and when you're doing modeling, because this can really change the way you model data. It can give you some flexibility. Let's say you have an 80-20 situation where most of the time I want to store it as a separate document, or I want to store it as a part of the document, but 20% of the time that doesn't really fit my requirements. So a subdocument is, well, I don't want to get the whole, I don't want to change the whole document. I don't want to send the whole thing over the wire. I just want to change the address. So with a subdocument API, we can point to the address and say, just give me that part, or just change that part of the document without sending the whole document over the wire. So it's a little more work there because you have to identify how do I get to that address portion of the subdocument. But it'll save you some performance to do that. And so this is especially helpful with large documents. If as we add, our document gets bigger and bigger, we don't want to keep sending this 20K document across the wire just to update one Boolean, for instance. Now in Firestore, this is something that I've added at Michael's request here. I looked into Firestore a little bit. I'm not a Firestore expert at all, but I thought it was very interesting to point out that there's something in Firestore called subcollection, which is not exactly the same as a subdocument, but very similar. So in Firestore, you can have a collection of documents. So in this case, rooms is a collection. And an individual document like room A can itself have its own collection, in this case, messages. So we've got a collection that has a document and the document that has a collection. Now you can do this in plain JSON, just about every other document database. You can nest as deep as you want to in JSON. And much like the subdocument I mentioned before, you can do a similar thing here. I can say, well, I just want this one message, and I can address that individual message. I don't have to get the whole rooms collection or even the whole room. I can just get that one message from the messages collection. So I think the way you address that in Firestore is like rooms / room A / messages / message one, for instance. The one key difference here is that Firestore treats those documents in the subcollection kind of like they were separate documents. So this is kind of an interesting feature. But this kind of the gotcha here is that if you delete a document, if I delete room A, for instance, the messages are not deleted because they're basically separate documents. Kind of a symbolic link there, right? So that's kind of how you can think about that. And be careful when using that because you could end up with some orphan documents or message one's floating out there, but we don't know what room it belongs to, things like that. But I just thought that was interesting to point out one interesting difference that Firestore offers there. Okay, so that's key value. That's the first one. The second one I want to talk about is querying. And most databases, most document databases these days offer some kind of querying. So I wanted to give you Couchbase as an example because it's the reason I work at Couchbase. The reason I love Couchbase is because it's SQL. You can still write SQL for a NoSQL database, and that's pretty unique. CosmosDB with Microsoft Azure, it's a dirty word to say around here in the Google Cloud group. They have a SQL language for Cosmos, but it's very, very limited subset. No joins, for instance. No, well, until recently there was no group by, things like that. But with Couchbase, you got the full ANSI SQL, the full gamut of joins, aggregation, unions, common table expressions, all that kind of stuff. Even though there's no tables, we still have common table expressions. So for instance, if I wanted to just filter to all users with a Visa or MasterCard, I just do a where statement here, where card type is Visa or card type equals MasterCard. Now the thing is, when you go into the realm of queries, you're stepping out of direct key value lookup. You have to go into the world of indexes. This is true in relational as well. Indexes are important in relational, absolutely. I would argue they're even more important in document databases where you have, instead of separate little tables, where, you know, I'm guilty of this. If I'll create a new little auxiliary table with 100 rows, who cares about the index? Full table scan is not going to kill me. But a full table scan, the equivalent of a full table scan in a document database, could mean I'm scanning 1 million documents, and that's just not going to fly. That's going to be a timeout. That's going to be a problem. So indexing is very important, which means there's overhead involved. So we're trading off here some flexibility in how we access our data for a little bit of performance, and that's true of any sort of index. But that's just the important thing to understand with this. So you have to be able to understand how that query is executing, understand the query plan. Now, Couchbase offers like a visual tool, same as like SQL Server, or, you know, I assume other relational databases offer similar query plan tools. So here's an example query right here. I'm not super relevant right now, but I'm getting all the airlines that have a name that have like US in the name. And so the query plan for that might involve all these different steps. We have to make sure it's authorized. We have to scan the specific index. So it's got to figure out which index to scan it. And then because I'm doing a select star up here, it has to go and do the fetch. So every one of these, I don't know if you can read that over the Hangouts, but it's 187 fetches there. And that means 187 key value lookups. Okay, because I'm using t.star, which if you want t.star, that's what you got to live with that. And then it's got to filter it here. So we're going to take that 187 and filter it down to 6. So you can see that's why these two are different colors here, because that's where most of the time is being spent. And then projection and streaming. And then with Couchbase, of course, we can then get other databases do this as well, like recommend an index. Say, well, your query ran, but it could be faster if you add this index, right? So don't be like me in the day and ignore this advice. Use the indexes. This will help you. Additionally, remember the t.star I mentioned there? You always hear never do select star. Never do a select. Put a star in your select. And the reason is if we don't need all those fields, we can create an index called a covering index that contains those fields, and then we can skip the fetch step completely and just pull the values right from the index. So that'll even improve the performance even better. But of course, that depends on your use case. Do you need t.star, or just do you need first name, last name, phone number, for instance? So we could skip that fetch step in some cases. All right, and that's true of any query language. So I know Couchbase is my favorite with the SQL, but there's others out there. I think Firestore has, it looked like Link to me a little bit. It's not Link, but it looks like a fluent query language. So it's somewhat limited, but there's still, you need to still think about indexing and what the path is that's going to take. It's a very important step. The last one I want to mention is full text search. So some databases, some NoSQL databases like Elastic or Solr, for instance. This on the screen here, this is another Couchbase example. This revolves around text. So things like, if you've heard these terms before, if you haven't, don't worry about it, but things like stemming, language awareness, facets, ranking, things like that are important for this. So this is a very simple one. I'm just searching for the keyword submarine, and that's going to return some results. So here's the documents that you've indexed. Here's where the word submarine appears in them, and it's ordering them by relevance. So it's not just whether it has submarine, but which one has the most instances of submarine, or you know, and maybe subspace marine shows up as well, or submarines plural would also show up because it's language aware. It's smart enough to understand that, okay, you're searching for submarine, you probably want submarines and subspace marine as well. So instead of using a like statement, for instance, in SQL, you'd want to use this, because a like is not a good substitute for a full text search. It's a lot of edge cases there. You're going to have a bad time if you've ever tried that. So that's another pattern, but it again requires some indexing. So just want to kind of sum up here, accessing your data. These are all going to affect how you store and how do you model your data. So key value is always going to be the fastest. And if you can, create a good key value strategy to rely on that as much as you can. Full text search, if you're doing text-based stuff, you know, geography, stemming, all that kind of stuff I just mentioned, language aware, you know, like a Google search basically. maybe a catalog search for your e-commerce project, for instance. It's well suited for that. And then a query, whatever query language your database supports. Couchbase is Nickel, Firebase, whatever. I don't know if they have a name for it, but the Firebase language or the Mongo language, for instance. Those are going to provide the most flexibility, but you have to have really good indexing to get good performance out of those. So I would take key value into consideration the most when you're doing modeling. Just understand you can fall back to other query methods if you need to get that flexibility out of there. Okay, that was the biggest section, I think, of the presentation. So I'm going to take a little drink of water here and see if there's any questions that have come in.
Oh, that's fantastic. In Firebase, both real-time and firestore index recommendations, typically you're accessing things through the client application, and so their index recommendations actually pop up in the console logs.
Okay, there you go. You just can't ignore them. And also, one other point to make with that is index recommendations are not going to be the end all as well. You know, you kind of have to use your own brain sometimes to come up with a better index. Like the covering index especially, only you really know, do I need all those fields or not, right? So you still have to use your brain. It's not completely automated just yet. There's still reason for us to be typing. It's not completely, you know, machine learning and stuff may help with that down the line, coming up with good indexes and things. But right now, you still have to use your brain a lot, unfortunately. All right, we'll soldier on here. So I want to talk about migrating data. And before I do this, I want to say, when I say migrating, what it really mean is, you know, moving data from one database to another. It doesn't mean you're replacing the first database or decommissioning it. You may be syncing it. You may be just exposing part of it for reporting purposes. You may be, you know, whatever reason you have. You may want to decommission the first database, right? We've heard a lot in the news about demand for COBOL developers. So one of the cases for migration here is those systems are very hard to just rip out and replace. But they don't scale very well because they were, you know, designed before the World Wide Web was even invented. So what you might want to do is you might want to offload some of that data into a faster, more scalable system while still maintaining the core business logic that's been built up in your enterprise over the last 30, 40 years. So that's another good use case for NoSQL. So think about that before you go into this. It's not just a simple matter of, well, I'm going to switch from database A to database B today. No, you're not. Not in one day. You're gonna have to think about this. But just keep that in mind. I'm not advocating you should all drop relational databases and switch to NoSQL today. But if you do have a project that requires multiple databases or you want to switch, you got to think about that going in. So there are some tools for this. Highlight a few of the good ones here. So you may have licenses for these already. Kafka is a tool that's kind of, you know, this is not all it does. It does a lot of things, but it can act as a connector, it can act as a source and a sink for data. NiFi is one you may not have heard of. It's actually very cool. It's a visual tool for managing the data flow of your whole enterprise if you want to. It's like you create a flow chart of your data and then press play and it starts moving around. It's amazing stuff. But Talend is a big one out there, Informatica. Those are big names as well. There's tools like, you know, ODBC tools, Dart, if you ever heard of Dart, Debezium, also Spark. These are maybe not Spark, but there's all kinds of tools out there that can help you move data around. So you may already know some of these, and most of these, in fact, I think all of these I've shown here have connectors to at least one NoSQL document database, and certainly more. So tooling is always good. Build your own is another approach you can take. So you may just write a Python script, for instance. It's a great language for moving data around, or a Bash script. Most databases ship with some sort of import-export tool. So Couchbase is CB import, Mongo is Mongo import. SQL Server has SSIS, integration services that you can connect databases, you know, connect SQL Server to other databases and vice versa. Oracle has the Golden Gate tool, which you know, may cost you a small mortgage, but you can use that to move data between databases. And so this is going to involve a little bit more work on your part to move data around and configure how that's going to work and set up the schemas and all that kind of thing with these tools, but that's another option. I would say if you're just starting out, just try to keep it as simple as possible. So if you're working on a proof of concept, for instance, this might be the approach you want to take. Before you invest heavily into a tool or building something on your own, keep it as simple as possible. So pretty much any relational database you can export to CSV. You can export a table or multiple tables to CSV. And most NoSQL databases have some sort of CSV importing tool. So you can import that data directly into, let's call it a staging area. Or I put a bucket on here because Couchbase calls its units of data, calls it buckets. So it has staging bucket. And that's just the raw data from relational to non-relational. Now, you could leave it like that to start with. You're not going to get the benefits we've talked about with data modeling, with all the embedding and the things, the aggregation that I mentioned. But that could be a good first step. And then gradually, or maybe in a big bang, you want to transform that data and like I said, aggregate it up to take the smaller auxiliary tables and collapse them into documents as much as possible. So you can take that final step of transforming data, maybe as you go, or in one big project if you really want to do it that way. You could use the query language like Couchbase uses Nickel. You could use that to transform with update statements, inserts, things like that, and insert from the staging into a new bucket, and just code that process all the way through and come up with a set of queries that moves the data over and also remodels the data to suit your needs. We're going to talk about proof of concept here, I think, in a second. I might have skipped it actually, but that's an important concept as well. And I would say, make sure you have a data model to begin with, and then align it, your migration goals with that data model. The modeling step is really, really important. If you want to just dive in and start moving data over, that's totally fine. But you're going to eventually want to take advantage of JSON. And if you don't, you're not going to see much advantage to a document database, because you're still going to have lots of pieces of data that have been run through the shredder that you got to put together. But yeah, keep it as simple as you can. Plan for failure. Sometimes, and maybe this is just me projecting because I'm guilty of this, but developers think of migration as a one and done kind of process. And the reality is it's often an ongoing headache that someone like DevOps or maybe you need to monitor to manage in a production environment. And so make everyone's life easier by thinking about the long game there as much as possible. And from experience, I would say with migration, you got to plan for things to go wrong. Failure is always an option. You may try out a migration process with a sample of test data and find out your source data is in production. There's some bad source data, some old records that are still hanging around there that, we stored a number in a varchar field for some reason. And it's just now someone's got, emojis in there. What happened? We don't know, but we have bad source data. Hardware failure could absolutely happen. In the middle of your hour migration, maybe a server crashes or something. So you got to be able to expect that kind of thing. Resource limitations. If you're doing a proof of concept with a limited set of data, you deploy it to production and find out that, whoops, I'm using memory too much. So now we have an out of memory when I try to load, 100 gig of data into RAM and then transform it. Well, that's not going to work. So yeah, it could be an ongoing headache, and you have to be able to recover from these kinds of failures. And so make sure that your migration process, whatever it looks like, can be interrupted if you need to. It can be restarted, and make sure it's logged as well along every step of the way, that it's logging what's happening. And this is all going to make it very predictable and very boring, which is what you want in a data migration. You want it super boring. So that's my recommendation there. So a few examples of what you might want this process to look like. So I'm just going to take a couple here. If we're going to use Kafka, for instance, Couchbase can be a source or a sink. It can be on either side of this. But in this case, we're setting it up as a source. So whenever data changes in Couchbase, it gets published out to Kafka, and then we can set up a sink to some relational database like MySQL or whatever, and that can consume the Kafka message and save it to a table or something. And we can turn it around in the opposite and do the same thing. Or maybe we want to use something like Golden Gate or SQL Server SSIS. And we set up a process so relational data publishes out to Golden Gate, and we have some sort of handler Golden Gate adapter, for instance, that reads the data into Couchbase. And there's actually a GitHub project that does that exact thing. CData, cdata.com, that's the letter C data. They publish a lot of drivers and tooling for this kind of operation. So you can set that up as well. It's not a simple just fire and forget sort of thing. You do have to do some setup and some coding with this, but that's one way you can do it. And of course, the fallback, which I wouldn't recommend, would be your first choice, but you can always do it manually. You can make the migration part of your application, even just have it sort of migrate in place if you want to go that far. The problem with this is it may or may not be reusable. It's going to be a lot of work. So if you go into the do it yourself completely manually, make sure you have a really good reason to do that. Okay. I'm ready to sum up here. I want to pause for more questions or comments here. Nothing so far, Michael? All right, so they say you only remember about 3 or 4 things from any given presentation that you sit in. So here they are. The first one, I want you to think about the right application. I want you to focus on applications that either you're building brand new or that already have a good structure in place, that they're microservices or they're SOA or something like that. Don't try to convert everything over to NoSQL just because you want to, which means do a proof of concept. Go through the modeling exercise, even just a small part of it. Make sure you have a focus. Make sure you have a success criteria. Use a tool like Accolade to do the modeling and be rigorous about it and collaborative about it. Match the data access to the requirements. So we spent a lot of time on this today. You can use a document type as part of your model. Make sure your keys are optimized and understandable. Think about whether you're going to nest or reference or do a mixed model between your relationships. Make sure you have good indexing and the right indexing to match your queries. And then I wrote a couple blog posts on proof of concept, so I guess I'm not going to go through all the details of this, but sort of the basics of how to do a proof of concept to move to relational or to think about starting with the document database. So check out that blog post there. And then I did a blog post that's sort of a shorter version of this presentation. It's about JSON data modeling. Now, those both have a heavy Couchbase lean to them because they're published on Couchbase.com. But most of the principles there would apply to other NoSQL databases. This is my gorgeous family. We were supposed to be on a cruise this week. Right now, we're supposed to be on a cruise ship. But this is a picture from our very first cruise. We loved it, and we can't wait to get back on a cruise ship, hopefully one of these days. But if you want to contact me, I usually say come see me out in the hallway, or we'll talk after the session, but we don't have a hallway. I'm happy to hang out here, but you can also find me on Twitter, mgroves. A couple of you follow me here from Twitch. If you want, some of you want to follow me back, I'm also Twitch/MatthewDGroves. I do a lot of live coding there, at least twice, well, usually around twice a week, regular schedule. If you have Couchbase specific questions, you can always go to the Couchbase forums and ask away. That's all I got. I do have this slide of FAQs that I get asked at every single presentation. So I have slides for those ready if you want to ask those. But other than that, I do want to say, before I turn it back over to Michael, that this is a really stressful time right now. And you all have chosen to spend about an hour and a half-ish of it with me and with this group. And I really, really appreciate that. And so thank you very much for hanging out with me. I would give you all a round of applause if we were in the room together. But thank you very much for joining me and Michael today. So I'll hand it back over to you, Michael.